In this video, I'm going to talk about Modus station equipment and sourcing equipment. So let's start with the basics. Talk about what each part of the station is. So you have a tower. That's kind of what everyone talks about, is a Modus tower, but that's basically just the structure that you're attaching your antennas onto. That's why you need a tower. You have antennas which go on the top of that tower, hopefully, and then you have a receiver, which is usually at the bottom, often stored in a storage case like this action packer. And then you have a power supply. In this case, we have solar, but it can also be AC. And lastly, which is not pictured, we have data flow. So sort of how you get the data from the station to Modus. So I'm going to go through each one of these one by one and talk about what you can do in those situations, for those equipment. For towers, we have a few different types. So one that we've been putting up a lot lately is this bracketed tower. So we call it a lattice tower. Sort of have a triangular shape to them, and they go up along the side of a building, like a house or something, and then you bolt it into the eaves of that building so that it doesn't tip over. The base of it's also anchored into the ground. These are actually very strong towers. They can last for many years. And so we've been putting out a lot more of these days, and they're really great. Probably the preferred tower type, requires not a lot of expertise, is relatively quick and robust, so long lasting. You also can put a standalone tower up, so this would be something like anchored in concrete. So the base is just a big concrete slab. These ones are a little more challenging to put up, not only because you need to be able to pour the concrete into a big hole and prep that section, but then you also need to climb the tower in order to put the antennas onto it, unless you have like a lift of some kind, like a bucket truck. But again, these are really, really great to have in places where you don't have a building available to you. And if you have road access, because obviously the concrete is going to need to be poured somehow. So it takes a fair bit more expertise, though, remember. So you might need to hire somebody to put up this tower. You can also put a standalone tower and guy it to the ground. You have similar issues with you have to climb the tower afterwards in most cases, but in some places where there's not really much for trees, if it's really rocky, you only need a really short tower, in which case you don't need to climb it afterwards. And so this is what we do up north oftentimes, where there is no soil layer and you have to drill directly into the rock and anchor it that way. The anchors that you use for the guy lines will depend on the type of soil. So yeah, if there's rock, it's a rock anchor. If it's dirt, you're going to use an earth anchor, and if it's sand and silt, you'll need a bigger earth anchor. Tripod and mast is something that we've used widely in the Modus network, but isn't very recommended anymore. It was sort of an easy way to get things started and put things out there. They're relatively quick, requires very little expertise to know how to do it. But they're kind of intended for temporary structures, so they tend to not last super long. They rust out or get damaged in windstorms. So they work, but it's better to put your energy into a more robust structure like the other three I showed. You can also talk about railings. So if you have a building like a lighthouse or a dam or something like that, where there's a lot of railings around, you just bolt a mast to that railing, and those railings are intended to be quite strong because they're supposed to hold the weight of a person at the very least. So they should be able to hold a mast, and we've done this in lots of locations. So if there's a railing, that's pretty handy to have, and they're really quick to install. Buoys are something that we've put some stations on, but not very many. Personally, I haven't done it. It's really for offshore applications. It can be done, but again, very challenging, especially because of the ocean conditions. Make it harder to put it out. But and really the main issue is sealing everything in a waterproof container, like the battery and receiver and stuff. That's been the main challenge. And then lastly, we have mast only. So this is basically just, it can be just a tree even, or a bamboo pole. This has been done in a few places in Latin America where wind is not a concern. Because if there's really, this is not a very strong structure at all, so if there's any kind of wind, it will probably break. But again, it's really cheap to install, really easy. So if it's in a place that's easily accessible and not very windy, this can work in a pinch. There's one more I haven't put here, which is the non-penetrating roof mount. So if you have a flat roof and you don't have permission or you don't want to drill into the building in any way, you can essentially put one of these on there, and it's basically just a platform that you can weigh down, which has these brackets on it to hold a mast. So I'll show a picture of that in the next slide. So here's a bunch of station examples in real life. So this one here is in Bahia Calden in Chile, on Chiloé Island. So we bolted this mast onto a school, and the actual pipe we got from local like oil and gas industry supplier. So there's just like a galvanized steel pipe that we found. So that was nice. And then the brackets that we used to attach it onto the wall, I couldn't find anything anywhere. So I ended up hiring somebody to make them for me. I bought these strips of metal that he could use and hammer out into this little loops, and then he drilled holes into them so that I could drill those loops into the building. So that worked really well, and often that's the way that things will go in certain parts of Latin America where it's harder to access the equipment that we use here in North America. There's a tripod example out in the field, so it works fine, but again the stuff is doesn't last super long. So this one was damaged in a hurricane a couple of years ago, and we had to replace it, the mast, which takes half a day to do. So it's not nothing. In Baracas, I used a tower that already existed and attached a couple of antennas onto it. But this is something important to keep in mind. So an existing tower is great if you could find one and get permission to use it, but sometimes they're kind of sketchy and you don't really want to climb them. So you have to be careful about this. Don't do anything you feel uncomfortable about doing. There's had a retaining wall next to the tower, so I could climb up on that wall and basically didn't really have to climb the tower to put these antennas on. We had a third antenna we wanted to put up, but I didn't feel safe going high enough to place that antenna, so we ended up getting two here, but it worked and we got lots of detections with it, so that was fine. But yeah, just keep in mind, if you're using a tower that already exists, it might be old, or maybe it wasn't installed correctly, or maybe it wasn't inspected after it was installed. So if you don't have the skills to climb a tower, don't climb a tower. It's a dangerous activity, and to do it safely, you really do need a harness, but not everyone's going to do that necessarily. And the next one we have here is the mast only. So in Colombia, this is just a pole, just a big stick basically with some antennas attached to it. So, and then I think there's some boulders holding it up. So that worked well in that case. But again, it would snap like a twig if there was a strong gust of wind. So most of the time it's not very practical to do this, but it can work in some cases. And then this one's on a railing on a lighthouse on Sable Island, so really high up there. and it lasted for almost, something like seven. Oh no, it was a long time. It was like, yeah, 7 or 8 years before we had to take it down because the lighthouse was no longer safe to climb. This is the non-penetrating roof mount. So you'll see on the bottom there's all these cinder blocks that are weighing down this platform, and then there are these sort of metal pipes that go up and circle the mast. So this works really well on flat roof buildings, so industrial buildings, stuff like that, universities. And then here's a bracketed lattice tower. So this is one we put up in Labrador up north. And it's really strong. It's a very windy place, so we felt safe putting this up here. And then we have this, what we call a climb shield around it to prevent kids or anybody else from climbing it and hurting themselves or messing with the equipment. And the very last one we have is a rock anchored guide tower. So it's another one of these lattice towers that was installed up in Labrador as well. In order to do this, we had to put the antennas on while it was leaning on its side on the ground, and then they tilted it up onto the rock, bolted it in, and then attached everything like a solar panel to it afterwards. So this is also kind of a test subject because we don't know if the polar bears are going to mess with it, but generally this is a good way to set up a station in most places. So I'll pause here just for questions, and then before we move on to antennas. So antennas, there are generally two types. We have what we call Yagi antennas and Omni antennas. So the Yagis are those long ones with a lot of, the central boom there is that big metal pipe in the middle, and then you have these little elements that are going vertically along it. So this one has 9 elements on it, so we call it a 9-element Yagi. The number of elements does matter. That affects the way it operates. So the Yagi antennas are considered directional antennas. So that means it's important what way you point the antenna. It also has a longer range than an Omni antenna. So an Omni antenna, it detects everything around it uniformly, and its range is more limited. So this 9-element Yagi has about a 15-kilometer range, whereas the Omni has about a 1-kilometer range. You can get Yagi antennas with fewer elements, and those would have a shorter range. And the way that works is that basically it becomes less directional. So if you can imagine, there's an angle. It's sort of the Yagi detects things at 30 degrees range. Basically, that's the angle at which it detects things. But if it was a 5-element Yagi, it might detect things in a 45-degree range. So a little bit of a wider area that it can detect things, but then that distance is shortened. To get a sense of what the shape of the detection beam looks like, it's sort of like this long, elongated teardrop shape, and then in the back there's these weird lobes going on. So just an artifact of the design of this antenna. That's what the lobes come from. Those lobes are only there to illustrate the fact that you can detect things behind it and to the side of it, but only at a very short range. So usually when you get a big detection on these antennas, it's because there's a bird flying in the direction that the antenna is pointing, or in that area where the direction of the antenna is pointing. And you can use this information to figure out direction of movement or where they're hanging out, those animals are hanging out. So if you look at the Omni antenna, instead you're getting this big donut shape around the antenna, and that's how it's detecting things uniformly around it. So that donut extends about 1 kilometer. Now obviously these are idealized detection ranges for these antennas. In reality, you're going to have much more limited and much weirder shapes than these. Essentially, it's because you're using these antennas in environments that are full of stuff, metal, trees, the earth, and so all of that stuff's going to affect the range of your antenna. And so in reality, you're going to get a lot shorter range typically, and in most directions, unless you're on the ocean or something like that. But if you're in the forest or on a mountaintop, you're going to have more limited range. And if a bird is sitting on the ground, it's much, much harder to detect it than if it's flying in the air. So keep those things in mind when you're putting out your towers. You can't just assume that it's going to go over top of a wall, for instance. It might get reflected by that wall. So when you're installing a station on a building, for instance, you'll have to be really mindful of where there's a metal roof or sheet metal walls, because that really can affect your detection range. Generally we say keep things like at least 1 meter or 2 meters away from metal objects like that, and don't point your antenna directly at a metal roof. That's not going to do anything good. The other thing to keep in mind is that the frequency of antennas is really important. We operate on 2 frequencies. One, that's 166.380. That's the frequency that low-tech operates on. And then there's also 434 megahertz. That's the frequency that CTT operates on. And as you can see, the 166 megahertz uses much longer antennas. And really that's because the longer the wavelength, the longer the antenna. And maybe it's a little counterintuitive, but the lower the frequency, the longer the wavelength. So yeah, it's when you're putting out these big antennas, you're going to need a more robust structure than when you put out these shorter antennas. Now, you shouldn't pick your tag technology just based on this. That's not a good enough reason to use one tag or the other. The tags are different enough that you should really pick your tags based on your research question and your study species, and then that will help you figure out what antennas to get. You also might want to pick your frequency based on what the other stations are in your region, because you might not get any detections outside of your own stations if you pick the wrong frequency. And the last thing about radios, or about antennas, are the radios. Antennas are basically big metal objects that are used to, pick up electromagnetic noise or signals in the environment, but they don't do anything with it. You need a cable, and then you need a radio to actually take that signal and record it, and to sort of translate it to something digital, so that our receiver can record it on its internal storage. So there's generally 2 kind of categories of radios. There's USB dongles, and of those USB dongles, we have the FunCube dongle and the CTT dongle. So the FunCube dongle listens to 166 megahertz, and the CTT dongle listens to 434 megahertz. And then you have the integrated radio. So certain receivers will have these frequencies, these radios integrated into the receiver itself, so you won't need a dongle necessarily for those receivers. And on that note, moving on to receivers, you have 3 different types of receivers. The first one here is called the sensor gnome. And this is kind of where Motus started with the sensor gnome. It's an open source project based on the Raspberry Pi, which is a well-known hobbyist computer. And it has 4 USB ports, so you can plug in those USB dongles into it, and no integrated radio. So for whatever frequency you want to use, you're going to need a USB dongle. But these are great because it can be a really cheap solution when you're wanting to put out stations and you don't have a big budget. You can build this one yourself. The CTT sensor station, on the other hand, is it has integrated radios, but only for 434 megahertz. Obviously, that's the frequency that CTT operates, so that's what they have integrated. It also has 7 USB ports, so you can plug in Fun Cubes if you want to listen to 166 megahertz. Now, the sensor station is in fact built using the same kind of equipment as the sensor gnome, so it's essentially the same thing, but with a different layout in a custom circuit board. The last one here is the Lowtech SRX. So this is the receiver that Lowtech makes for their tags, and it has integrated radios for its frequency at 166 megahertz, and it has no USB ports. So if you wanted to listen to CTT frequencies, you just can't with these ones. They're also a bit more expensive, so people tend to not use these ones, but they do a much better job at detecting their own tags than any of the other two receivers. So there can be a reason to use them, but generally people don't. So just to go through those details a little bit again, but in a different format, the cost of a sensor gnome is the lowest, but in order to get that low cost, you're going to have to build it yourself. Otherwise, if you buy one pre-made, it's pretty similar in cost to the sensor station. So if you're going to get them pre-made, you might as well get a sensor station. Both sensor stations and sensor gnomes can connect to our servers and upload data automatically using either Wi-Fi or cellular networks. The sensor station also has the option of satellite connectivity, but it only gives you diagnostics data. So that's stuff like voltage of the battery and I'm working, but it doesn't actually tell you what it's detecting. So it can be helpful when it's placed in a really remote place and you want to just know if it's working or not. And the Lowtech SRX tends to be a higher cost and doesn't offer any form of connectivity to our servers, but it does have these integrated radios, which is nice to have, but not necessary. Moving on to power supplies. So, this one's a bit more simple. There's really just 3 options here. You can either just plug it into a wall outlet household AC. This is by far the best option, just because it's cheapest and the most reliable. In some places, I recognize that AC isn't that reliable, that there's outages that occur frequently, and sometimes they can be for an extended period of time. So in those cases, just consider using an uninterruptible power supply, or UPS. So that helps stabilize the voltage of the power, but also if there is an outage, it can keep the station running for several hours. So these are helpful. They're a bit expensive and not necessarily available in all the localities. You might have to import some, but it's worth looking into if you foresee this being an issue. Solar would be the next option if you don't have power, AC power available. The cost is generally a little high because you want to make sure you have enough solar panels and batteries so that you're not ever limiting the amount of power the receiver needs. But it can be very reliable if you do get enough equipment. So I would say it's about $800 to set up your solar panel with the battery and charge controller. So it also just increases the amount of time you need to set up your station. And then rarely, but in some cases, you can also use batteries only. So that's basically just powered straight off the battery, and once the battery dies, your station turns off. So that means you'll have to swap out your battery on a regular schedule in order to make sure that the station maintains power throughout your study period. So it really makes sense on these smaller scale studies where you're looking at landscape use. Um, the people who do this tend to have lots of stations in a small area, and they're swapping out batteries every couple of days. And so it's a lot of lugging of batteries, which kind of sucks. But those places tend to be, they don't want to put out solar panels because there's a lot of people in the area and they're worried about them becoming targets for vandalism. So that's another important point about solar powered stations, is that people see a solar panel and they see money. So you want to make sure that wherever you put a solar panel, it's going to be in a secure location. And the last piece is data flow. So how are you going to get data to Modus? And I've already mentioned a couple of these things, but generally you have the option of manual downloads or automatic downloads. So manual downloads is kind of what it's, you might imagine. You just go to the station, plug in your, or connect to your receiver with your laptop or phone, download the data, and then you'll later upload that data to Modus from your laptop. Automatic, you'll be using Wi-Fi or cellular to upload data automatically to Modus, and this is obviously really convenient. So remember, satellite doesn't work to upload data right now, but I can at least tell you that the station's working. So you can just maybe download data manually once a year instead of having to visit the station 3 times a year just to make sure it's working. So there can be benefit to getting satellite data, but it's limited. And just to illustrate why it's important to get automatic uploads, checking a station is expensive, even if it seems like an accessible location. I did a quick cost analysis for our local network, and I found that it cost at least $300 to check any given station. And on average, it's about $350 per station to check it once, which sounds outrageous, but I'm adding together staff time plus fuel costs plus food plus lodging for these expeditions that we do. And so you can really save a lot of money if you're paying, even if you have to pay for data charges for your cellular data or whatever, you still save a lot of money. So it's not just that, it's like your time is precious usually, so you don't really want to be wasting time if you don't need to. Now I want to talk a little bit about sourcing equipment just to get us started for the breakout groups. I want to talk about how I have personally found equipment in different places and what I've heard from other people. But it's really like you do have to be very resourceful, obviously, in a lot of situations. It's not always going to be practical to import equipment, or it might not be possible to order it to your location. So you will sometimes just have to figure it out for where you are. So asking around is one big one that's can be really helpful. Just trying to think about who in your location might know this kind of thing. Look for people who have towers and ask them, see if you can ask them how they got their tower, what they did, how much it cost, maybe. Find metal fabricators. So people who work with metal will often just build stuff for you. Sometimes you can buy the metal from them and then they'll build it there, or you'll have to buy the metal somewhere else and then bring it to them. They will need, diagrams and pictures of what you want, but depending on who it is, they might have a pretty good sense of what you need anyways. It's a lot of these things are handmade in Canada anyways, in a factory, so obviously those are experienced people making them, but these can easily be made by people in other places as well. So for example, in Tierra del Fuego in Chile, those stations there were made in this manner. So we just show them a picture, we want this, and then they made some. And those are those sort of triangular lattice towers that we had made down there. Oil and gas industry is really helpful, actually, if you're in a town that's like an oil town or there's a lot of oil and gas in the country. They have a lot of equipment or they use a lot of hardware that works well for towers. So mainly just metal pipes or just angle iron and stuff like that. The pipes they have will often be corrosion resistant, so you want like a galvanized steel, or you can get a really thick aluminum pipe. And I found it be surprisingly cheap in Chile, at least. So there's some places where you can get good prices on this sort of thing. Radio operators, I mentioned asking around. So what I mean by radio operators, there's a lot of hobbyist radio operators who have a lot of know-how about how to do radio in their region. So looking for local radio clubs, which is a big thing globally, because people like to send signals to each other across the ocean. So there's people everywhere you go who are big radio nerds, and they tend to really love Modus. Put a lot of effort into helping people out who have Modus. So keep that in mind, and try to maybe look up on the internet for if there's any local radio clubs where you are. And then finally, use existing towers. Like, this might seem like a pretty obvious choice, but people don't think about this all the time. Existing towers are by far the simplest thing. It might not be easy to get permission all the time, but it's worth asking if you can just put your station on their tower. Keep in mind, you don't want your antennas to be getting any interference from their antennas. So it would be good to ask what frequency they're operating on. And if they're concerned about your antennas causing interference, just let them know that you aren't transmitting with these antennas, you're only receiving signals. And so that should help a lot to convince folks. Antennas and receivers are especially difficult to source in Latin America because you can't just use anything. You have to use the equipment that I already listed in this presentation earlier. So what you tend to be dealing with is import restrictions, or just the ability to get a courier and the timing around that. So we've had a lot of challenges like that in the past. So you will just have to be a little resourceful here, figuring out how to do that. Finding partners potentially who could bring equipment to you from Canada, United States, or when you're traveling abroad to bring equipment back with you in your luggage. Sometimes that's the easiest way to get stuff. It's just like, generally you're not breaking rules for bringing stuff in. It's just that the equipment that you're ordering looks like something that is suspicious or of value, so then it slows down import quite a bit. Now for power supplies, you should be able to find solar power in pretty much anywhere. So that's not always an issue. In some places, like Cuba, it was an issue, but generally it's not really a problem. The main thing you want to make sure you do is get a good quality battery, something that is actually designed for solar. So this would be like a sealed lead acid battery. Don't get a marine battery or a car battery. Those do not work very well. So yeah, now it's time for questions in the breakout group. So I'm going to end the presentation here and let Erica and Amy take lead.